Hello, my name is Gabriel Seelig.
I'm Rebel Berhane.
And I'm John Brown, and this is our bottle opener fixture.
We were given the dimensions of a bottle opener that was to be machined with a CNC mill. A traditional vise would be unable to hold the part for machining.
Our objective as a team of 3 was to design and manufacture a CNC milling fixture to machine a 2-operation CNC mill part using Mighty Byte Fixture clamps, SolidWorks HSM Works, and the Haas VF2 CNC mill.
In general, our solution was as follows. We took an existing part in SolidWorks, a catalog of Mighty Byte parts, ground fixture plate, and drawing with G&T callouts. We used all of these components to design a fixture in SolidWorks. Using HSM Works, we generated the tool paths to manufacture the fixture plate. We then assembled all locating rails and clamps. With the completed fixture, we conducted a 2-operation milling process to produce bottle openers.
Our project was subject to the following constraints. We were given a ground tooling plate, and our fixture must be able to mount in the Haas VF2 CNC mill. The fixture must be able to hold both CNC operations simultaneously, and the clamping forces must withstand the tooling forces with a safety factor of 2. Finally, we must use Mighty Byte fixture supplies available.
We took the following steps to create our fixture. First, we looked at the part drawing with the GD&T callouts. We used this to determine what datums were most important. The first datum we used for the primary was A on the flat fixture plate. Then we put it up to datum B on a locating rail, and the same for datum C. These datums were located with Mighty Byte rails and held in place by Mighty Byte clamps. Performed rudimentary cutting force calculations and found there was only 20 pounds of tangential cutting force, and that the Mighty Byte clamps would provide adequate clamping force.
Fixture geometry was modeled in SolidWorks, and the tool path and G-code were generated using HSM Works. We ran a machining simulation to determine that the fixture did not interfere with the tool path.
This is the final design for our fixture. There's a pocket and a slot for our rails to make sure that they are not improperly located. There is a pocket and a slot for our clamps in Operation 1 as well, so that they do not interfere with the tool paths.
We also cut slots for the T-bolts in order to attach to the Haas VF2.
The following DFM considerations were observed in our project. We used standard size cutting tools and standard size clamps and rails. Also, we used internal radiuses for all slots and pockets, so that a standard milling procedure could be used to machine these features. This fixture was designed using single-minute exchange of die principles.
The fixture was machined using a single operation on the Haas VF2. It was clamped with a soft jaw vise and probed such that the working coordinate system would be in the middle top plane of the part.
We then assembled the fixture, and this was bolted to the VF2 and aligned using the milled indicating band. 2 working coordinate systems for Ops 1 and 2 respectively were found by probing the fixture rails. 6 parts were produced using this fixture. Operation 1 had a load time of 15 seconds, well under the constraint of 1 minute. It had a run time of 8 minutes. So one major design flaw was that when you're moving the part from Op 1 to Op 2, the second Mighty Byte clamp is covered up. As well, due to the part variation or maybe the manufacturing variation of this hole, it didn't actually fit smoothly in the fixture. So the way we fix this is by just removing this clamp. And it turned out that the cutting forces were small enough that it wasn't actually necessary.
Operation 2 had a load time of 28 seconds, also under the 1 minute constraint, and had a run time of 3.5 minutes.
Our parts suffered from one major defect. Parts shifted slightly in the x-axis in Operation 2, causing the chamfer to be too heavy on one side and non-existent on the other side. We believe that the chamfer defect is due to the removal of the second Mighty Byte clamp, which allowed the part to shift slightly in the x-axis.
In conclusion, we were given a bottle cap with GD&T drawings, and we used this to make a fixture utilizing SolidWorks, HSM Works, a Haas VF2 mill, and Mighty Bite clamps and locating rails. In general, we had good quality parts and no catastrophic failure of the fixture. However, we noticed some degrading of the quality over time, as we mentioned with the chamfer issue, due potentially to having to remove the Mighty Bite clamp from the X direction. If we were to redesign this fixture, the first thing we would do is add slots and pockets to the Operation 2 rails in order to locate them properly. Second, we would drill a hole above the X-axis clamp on the Operation 1 workpiece so we can reach it for Operation 2.